Hello everyone. Now we will look at the task number 1 from the Perl Weekly challenge number 70, and the task is about swapping characters. So what we have a string s of size n, and there's also the swap count $C and offset $O. I believe this is O, not 0. There's some relations between them, so basically together they will not exceed the number of the characters in the string. And write a script to perform character swapping like this below. But actually there's an update which I didn't see when I was solving this solution. So Pete Houston suggested to put additional constraint as $C is less than $O. He presented the use case. Okay, never mind. So it's not that important at this moment. But let's look at the task. So we have to swap two characters in a string. And we have to take the first character with this index, the second character with that index. So basically it's the first character, the second, the third, and the last character, the last like defined by this input value, right? So we swap the first character and everything else, and the last character, the character with some number. And notice that there's no 0 here, and the same character with this. So the last character is $C plus the swap count plus some offset, right? And if we will take into account this consideration, so it means that so basically this, right? $C plus $O is less than or equal $N. So what we can have here in the worst case, this sum is N, and if we substitute it here, it will be the first character, right? So the last character will be, or the last character defined by C will be swapped with the character at position 0. So, and here's some note from my side. Basically there's no 0 here, so at first you can think that you never swap character 0, number 0, but actually it can happen if basically this sum is n, and then you swap it with the character at position C. Again, the second note is that this modular it looks like it's not really necessary because $C is always less than n, and actually if $O starts with 1, then $C is always less than n. So this one will never actually be needed. We will never go above this limit, but it's not the same about the second part, about the second index on the right side. So this one is still needed. And there's an example with some string, and after a few swapping we get this output, right? Okay, so let's go straight to solutions. Challenge number 70, recap and Raku solutions. Where are they? Right, Luca Ferrari, Raku number 1. So here's the solution. So we take the input string, there are some input numbers, $C and $O, with some limitations. So $C is more than 1, and altogether they should also, so basically this is $S dot chars is $N in the input task. So here is the n, yeah, basically. So yeah, we define it here. Yeah, I wonder if we can just, by the way, introduce this $N and put it somewhere here. Sorry, here in the block of the where clause. Right, so we print something, and then characters, splitting characters in the screen. Again, here I would suggest to use comb instead this construct with split. Then from 1 till $C, so all those rows in the input task, we will make some swapping. Swapping happens here, and for that we need the left and right indices, and this is just by definition the current number modular n and the shifted current number again with the modular. So I believe this module will never be computed, and the swapping in Raku is really simple. So you have two characters on left, two characters on right, and they will be just swapped, and there's nothing really difficult here. So just index for the left character, index for the right character. You've got these characters and you swap them, and then you print the result. Okay, so what I need to run it, I need this string. So maybe I will Luca. Right, so I want this string in my buffer, right? And let's run Raku Luca 70 Raku. Oh no, sorry, this is already 70. Raku number 1. We need a string and then C and offset, right? No, it's not that simple. Is it str of? Where does the string come from? Right, input S, input C, input O. But why is it M? Because I believe this is a challenge number. Okay, right. Challenge 70. Raku Luca Ferrari Raku 1. So okay, so we can run it like this. Yeah, hooray. Right. Okay, so this is the Pundrair Laku. Is it the same? Right, Pundrair Laku. Right. Okay, so it works, and the thing to look at is this one. Probably we can make it a bit shorter, but nevertheless, swapping is really a simple thing. Raku number 1 from Mark Anderson. Okay, so again, there's the main function which takes 3 arguments. There are some limitations, and the number of characters in the n, in $n, here are the characters. I see. So comb is used here, and oh, now nice, interesting. So then we use map to scan this range, and for each number from this range we make this. Basically this is the swapping of the characters. But unlike the previous solution, you see what we are having on the left and on the right side of the equation equal sign is the slice of this array. So there are 2 indices inside this, here and here. The only thing that probably can be make differently here is that these numbers are calculated twice, on the right side and on the left side. Then we join these together and print it, so we can run it. So Mark Anderson Raku chair 1, right. It goes in different order. So the first one is O, C and O, so 3 and 4, right. Pundrair Laku, right. Okay, now Raku solution. Right, there's one function, okay, with these default values, and we're calling this function what we're doing. So first we're preparing some space for the new string, and so it's not modifying in place the original string, but it's create new variable, and it replaces characters in the new S variable. Actually, it looks like a bit redundant, because we can just add isCopy here, $s is copy, and we can just modify this instead of creating a new variable. But nevertheless, so in loop, again, the same range. What we do substitute RW. So we select the character to be replaced, and right. So this is why we need a separate variable, because basically we take the original value from the original string, right? But I wonder if it's correct, because we in the loop what we have to do is to swap the first character with some character on the right side after the shift, then the second no, actually no, because we will always move to the right. But what happens if we will move, if the shift is not that big, and we will just reach in the first scan on the left side of the swapping swapping pair, will reach the edge defined by the shift value for the first character. So probably, I don't know if these values are not the same, will the solution work? Maybe yes, I don't know, but yeah, we have to test it, or you have to test it at home. Raku node, Raku challenge number 1. There are defaults there, so this one prints the result which is correct. So yeah, I wonder if this will be correct for other values. So we can, for example, yeah, we will not do it, but nevertheless we can use other programs as a reference point. But okay, so what is interesting here, in any case, there is an interesting moment here, is this method which is available in Raku, substitute and replace in place. So it's not just the substring which returns you a string, the substring, but it returns you something that you can assign to. So it's an L value, and you can assign to it, and basically you will replace the substring with something, which is really nice feature. Shahid, brief solution, but what we see here is, again, what is n? So n is not defined in this program, so I will not run it, but yeah, basically n is the length of this string, $s point chars, and we use slice array slicing to swap the characters for this range. And you see, so there's no %end on the left side here, and definitely on the right side here, which is a correct thing. Simon Proctor, here's the solution. The main function takes these 3 values, and there's the condition, right? Nice. So swaps are the characters from the original string. N is the length. Then we go again for this range. We compute those indices, which is a really good thing, because then we can just write it like this. So again, we are swapping using array slicing. And the good thing here is that all those indices are already computed, and they are computed only once. Yeah, definitely this program will be as fast as this one if we will not pre-compute this, but in any case it's a bit better. But yeah, let's run this program. Raku Simon Proctor Raku chair 1. So what's the order? So this one, right? Yes. Okay, then we go to Arne Sommer and his solution. So I accidentally clicked on Perl solution, and probably we want to see this these 2 strings here, where we swap the characters. And you see, so in Perl you can just use substr without any modifiers like rw to swap the characters, right? So you take one character, the second character, and then you swap them, and you assign those 2 at the same moment just by using this substr. Right. Nevertheless, let's go to Raku solution, and the Raku solution is right. So what we have here, so it's unit sub, right, as usual. So this is the main function. $s is copy, so we're going to modify it in place. Pos in, wow, pos in. What is pos in? It's positive integer. It's subset of integers where the value is more than 1 or equals 1, and default is 4. There's C with some limitation. This default value, right, and they've said right. Okay, so again, so this same range as we saw before, some output, which is really useful when you depart the program. Just print what you're going to do, what the program is going to do. And then we have, yeah, basically we just saw it in Perl solution, and it's the substr rw. So we can take this one, and instead of like directly taking the character from the array, you can take a character from a string by using this substr. I wonder why does Raku have no why you cannot use indexes in and apply them to a string in Raku. It would be a bit cleaner in the code, but nevertheless, so you can use substr. On the right side, you can use regular substr, which will take you give you 2 characters, and on the left side of the assignment, you will just use this modified version of substr-rw, so you can write the character to this position. Yeah, to this position, because we only take 1 character here and 1 character here, shifted by this $O. Right, let's run this. Let's run this Raku. Right, yeah, so it works. Going next, Athanasius, solution number 1. Yes, the description, copyright, begin. Right, so you see an interesting use case for the begin clause. The begin, it's not called clause, it's begin phaser. You just print some welcome or informational message in this begin. Right, then the submain with some limitations for the input variables. And notice that these Unicode fancy characters are used here. This is really nice. Right, so there are some limitations. Okay, then we take this small lowercase capital or lowercase s, this string, and we immediately nice. Notice this indentation here, so that just equals signs and $s is aligned, vertically aligned, and then we swap. Well, I believe 2 characters based. Okay, so we passed shift here to this swap function, and we repeat this action for the range, right? And the position is in $_, which is the second parameter. So here it is index. This is the swap function. It returns string. Right. So what do we have here? So we compute the length of the string. Then we compute the position of the left character and the right character. And you see, so again, alignment is really interesting here. Then we, after we know these positions, we take the characters themselves, and we prepare the new string, and we just make these replacements. But I wonder what we're doing here. So, right. So on the right side, we have the character from the original string, and on the left side, we are modifying the new string, and then we'll just print this. I believe this is the same as we saw a couple of solutions earlier, where there was also a new string, separate variable for the new string, and we were not actually swapping the characters. We were taking the characters from the original string and place those characters in the positions in the new strings, right? In the new string. So we were swapping the original. We were taking for the swap. We were taking the original characters instead of the characters which might be there after the previous swaps. Yeah, basically, probably this moment, it's a subtle moment, but it should be described in the task definition that we really do swap in one after another, or we take the original. Probably, actually, yeah, I think I would say we do it one after another. So this is not really what we are expecting, but nevertheless, so this I believe this solution will work for the given string. Raku share 1 Raku. So I believe I will find some values, so non-empty string, and there's so copy in here, right? So here's the Raku. So yeah, we will have to. So for example, okay, so this is the what is it? It's swap count. So we are doing 3 swaps, and the offset is 4. So yeah, if the offset okay, so actually maybe everything is right, because what are the limitations for the swapping input parameters? So right, so actually they will never overlap. So this solution is perfectly valid, right? Okay, so yeah, so it's really nice to just understand what's the meaning of all those restrictions in the beginning of the program. So here, so the count is always less actually equals then the offset. So we will never meet the situation when we are taking the character which was already swapped by the previous swappings. And what happens if it's equals? That's the question. Again, the new homework. Right. Going back to the solutions. So Athanasius' solution works, and then calling crane is the solution. Right. So there's also function swap, which takes the string which we will be able to update in place. So after the return of the function, this string is modified, and I believe we can just call it recursively if we need, and the string will be passed deeper and deeper, but not in this program. So in this program, so we've got this copy of the input string, some parameters, right? Then we swap characters, and then we do the main action. So n is the length for this range. We're doing okay. So the swapping is done using a temporary variable, right? Temporary variable, and yeah, basically all the other elements we've seen earlier, the substr rv can be used as an L value. And right, so probably this one is, again, it's never used for valid input arguments. So okay, let's run this solution. Raku calling crane Raku chair 1 and the input data. Right, so the start Ponder Raku. Right, so it works extremely correctly. Okay, next solution. Right, so it's here. So input restrictions, yeah, and again using the temporary variable we just swap them, but this time we prepare the indices before we do that. And notice that instead of single quotes you can always use this construct if you prefer this. Raku, right, Jaldar Raku 1 numbers 3, 4 and the string. Right, okay, Javier, Raku number 1. Raku number 1, yeah, so we immediately switch to this function with some default values, hard-coded default values. Number of characters, we split the string using this heavy construct, comparing to using com. Then loop, the C-style loop, and actually, yeah, sometimes these loops are handy if you modify the variable, the loop variable inside the loop, which is not really nice in practice, but nevertheless you can do that. But here it's just a loop to increment this $i, and we are using a temporary variable to swap the characters. Javier Raku chair 1. So yeah, we don't need any input. Right, okay, so Laurent Raku. This is the second solution with gray code. Let's look at the first solution. Right, so yeah, here we are. So what do we have here? So here we have this subset of integers with all positive integers. There are some redefinition of square brackets. We will take a look at them a bit later. But the fact is that I just mentioned a couple of solutions ago that Perl 6 is lacking this modification, the possibility to subscript the string, and actually here is an attempt to fix this. Right, so the main function, so we're going to modify the function. There are some defaults. Right, the length of the string die again, so instead of using the where clause in the main function, it will just die inside the program. And then for this range we iterate over the characters, well, actually over indices, and we are trying to swap the characters using a third temporary variable, right? So how do we do that? So here you see, so the intention is that here we have the string, we have its index, and we want to return the character to which we potentially can assign. Actually, it doesn't work. I spent some time to understand how it works, but here at least the part for reading a single character works. So this perfectly works, and this is why I have here again substar RW, because you cannot use something like that on the left side of the assignment. So let me show how this works. Well, this program definitely works. Lauren Raku, and I need the character, the string, I believe, right? I have it here. Right. Cannot convert, because again, so yeah, the second solution is really willing to be run. All right. So let's copy this one to here. Okay, so the idea is that instead of this, okay, let's maybe, right, so we can do something like that, right? So we can directly assign to this, right, like this. Yeah, we don't need this one because the length is always one. It's defined here. And this second function, by the way, is meant for ranges. For example, we can like 3 or 5, right? And this function will be called, and it will return the substring of like a few characters that we can assign to later, for example. Right, but let's not look at this function right now. And this is the program that I want to run. And maybe, yeah, maybe it's better to do it like this. Okay, let's make it strict. Right, so this is the function. All right, but if you run it, you will not get what you want. And of course, right, get the string again. Right, so index out of range is 1, should be in 0, 0. Well, the question is only 1. What? And the answer is basically here, when we're trying to assign, and actually this error message came from this piece of code, so it's line 14. So when we are trying to call this function, yeah, basically this value is obviously like 1, right? On the first iteration. No, it's not 1, right? No, 14. So line 13, index is 1. But nevertheless, so it means that actually this function wasn't called, right? Because it looks like we're trying just to print something like this, and you can't do it with the string without. So yeah, with 0 you can't do that. You will just get the whole string. For example, Raku, my S is ABC, S0, it's the whole string, and S1 is this error. Right. So what we need to make something so that we really call this function. So let's, for example, first look called with N4S, right? And let's see what it does. So we see called with the value of N is 1 and 5 for this string, and after that we meet this error. So we see, so 1 is here, it was okay because there's another call, but then we have 1 again, and this time this is an error. So what is the problem? So the problem is, yeah, I really spent some time. It's really dark corner of Raku. So what I'm suggesting to do is to like define this just keep this variable hello world. My n is 3, and instead of this, let's just look, and this is all. Yeah, we don't need it at the moment. So this is an array which will just grab everything that was passed to this function when it was called. Right. Okay, so it works now, so there's no mistake, there's no error, but I want to see what's actually in that array. Yeah, so you see, so what's going on here. So sometimes you see that there are 2 elements in this array and sometimes there are 3. So where do they come from? Basically, this is where they come from. For example, right, so see, this is the string. So basically, when you assign something, you actually call this operator redefinition with 3 arguments. The first is the string, the second is the index, and the third is something that you're trying to assign. So basically the right side of this assignment. So we need 3 arguments here. So let's restore it. String int. Why is it int? It should be non-zero, right? Yeah. But okay, n and, for example, some string replacement r. Right. Okay, replaced to this, and now if I will call too few positional, right? Too few, because this one is right, is an optional thing. So as we saw, sometimes it's 2 when we just read a character, and we've got 3 elements when we are trying to write to a character. Okay, there are some stuff we are not worrying about now, but you see, so sometimes there is something on the right side. So definitely there are different characters, and see they are really different at different calls, and they are passed here. Okay, so what we have to do is basically well, there are 2 options. First, there's return rw, which we can use here, right? But I believe this is not doing anything. So we've got this string. We can try to use rw, but is right. It's not doing it again. So what I suggest to do is just to do it like this: is if we have a replacement, we just get it. Otherwise, we just return this, and actually there's no need to do it like right. Yes, so now it works. Definitely. Yeah, basically, yeah. So yeah, I really want to. I don't want to compute the character for the second time if there is a replacement, so we do, but you can, maybe you can do it something like that and return and yes, otherwise do it like that. Okay, so from this point you can optimize this program definitely. So there are at least 3 things you can try. So you can use this substar rw here and make this a common code for both branches when r is there and when there's no replacement. The second thing is just make return rw definitely with this, so that you can directly assign and yeah, maybe like for example, if there's r, you can return this. If there's no r, you just yeah, I will try it. I'm not sure that it will work. So for example, so this one was working code. If r, then return this character, right? But we already know the replacement at this point, so we can just directly assign it as I did it here, and else just return again this one, but we don't need to rw, and I'm not sure that we really need this one, right? Yeah, so it doesn't work. Okay, so yeah, this is the homework for you if you want to make this function a little bit more efficient, and but it's already effective enough, right? Return, and I don't need rw, I believe, right? Right. Okay, so this is the possible solution, and this one is really important thing because we are going to modify the string here. So, but the thing is that we made this possible. Right. Okay, so yeah, let's stop here. Let's move next. And the next solution is from Mohammed, Raku 1. Here is the solution. So main function, default named parameters in the input. And yeah, so we are printing something joined by fat arrow, and this something is the string and the swap function, the result of the swap function, which is taking the string and the basically the count and the offset. Length is the length of the string, the Unicode version actually. Array is array contains characters of the string, comma, and again for this $1 to $C count, we make some preliminary computation of these indices, right? And then we just swap and we return this array joined. So basically we already return this the new string. Raku Mohammed it's here. Raku Mohammed Raku 1, and I need, okay, there are some defaults there, so it works, right? So it was this and it became here and became that, right? So what's next? Next there's another solution here, right? I will not focus on this because this is already we saw a few times. Lengths, interesting. So yeah, nice, an interesting pattern that you can use to print to std error. You just print something so that you can filter, for example, the output in your shell. So the only thing goes to std out is the result. All the rest is some additional information that you can filter. Right. Okay. Then my key. So this is the flag indicating that. I see. So if the so if this count is more than offset, then basically we know that this will lead to some overlapping during the swap loop, and so this is the place where it's used, and this is so this is Boolean value and we use it for multiplication. So right. Okay, so let's see. Interesting. So with s, so this thing just topicalizes, and inside this topic variable you've got basically kind of a link to s. Well, I think it's bound, right? So the result. So we're collecting result of a few substrings. So the first character is always there, so it's not wrapped. It's never touched because we do not have any overlapping, and we don't have such indices which will be more than the length of the string, right? So we can just keep it, and then and then we have a range, right, from count plus count plus offset, but this is 2 for some reason, right? Then if this is bigger, then count is bigger than offset, so we could just move our position a little back, but okay, let's ignore this. So if it's the correct case, then we have this range from basically from the count plus 1 position till offset. Then maybe there's some explanation, I don't know, there's no blog post about this solution, and then so all this is concatenated, right, using these tildes. Then we have part number 4. What is so and then finally there's again the range. So so here we are trying to just immediately, so you see there's no loop here in this solution, so I wonder how many times to change more than one default 3 offset between character so I wonder what if these are different. So right, and nevertheless, let's run this. Raku jo right Raku Chuan. Yeah, characters are there. Output right. What if I have C is 4, O is 5. They're not named, pardon me, so you don't have to do it like this. You cannot do it like this, and you also need this string here. Almost Raku. I don't know if it's correct, right? Yeah. Yeah, okay, so yeah, that's not homework for you, but the thing is that so basically we always take the first character, the original first character, and then we concatenate some substrings that are based on some ranges of indices. Yeah, right, it's really especially like this one. So I believe if this is false, then this part is not added to C, and here is, wow, what? So yeah, this is K. It should be okay. So let's run Raku. My K is 10 more than 5, right? My K is 10 more than 2, right? So this is true. And for example, if you will 7 multiplied by K, what do you get here? It's 7. And if K is false, 10 less than 2, 7 multiplied by K is 0. Okay, so this is what actually is using here, and I believe is as well here. Right. Okay, so yeah, maybe if we will just write it in a single line with some and remove these, and maybe you can understand this. But in any case, note that all these dots are applied to a topic variable, which actually is $s at this moment. And the beauty of this solution is that there's no loop. That's the really interesting fact, and actually loops are indirectly introduced probably by these ranges, right? But again, there's no, yeah, so we're trying to compute. Now I think I understand this. So we take the first character, then we take everything which is before the first position, right? Then we take in the end everything which is at the end of the string, which is not changed after swapping. And so this C+1, so I believe so one of these ranges should go, well, no, we cannot make ranges going counting down, right? Okay, yeah, so yeah, I'm a bit stuck here. I will not spend your time, and I will just, but that was really an interesting idea. And then we'll go to Roger Bell West, which gave us this. So there's a swap function, there's a test immediately using test, and there's only one test with these defaults, right? And the swap function is doing the following. So it takes the lengths, it splits the characters, the string into characters, and for this range, yeah, basically it does simple thing that we know. Raku. Yeah, so it works. So this is the expected result, and it's there. And the final code from Ulrich Rika. Right, so the main function is modifying the input string lengths for range swap letters. So in this word, so we see, so what is here, what is there, so, and then we say it, we print it, and it's like for each pair of indices we do this swapping. And again, so we take this character, and subster RW is our friend here as well. and yeah, we're using temp. So here we could just avoid this temp by assigning lists, right? And yeah, maybe an interesting thing to note is this: the return type of this function is defined in the signature of the function. Right, finally to my solution. My solution, where is it? It's here, Raku number 1. So what I did, let's look at what I did. Yeah, basically nice and fancy. So there are some inputs, then characters, then a range of for replacement, and yeah, so yeah, basically I'm computing the second index. Yeah, so I avoided modular here, but I kept modular there, and right, it prints this. Right, so maybe we can just, as a bonus track, we can just go back to this solution and what? It's Perl Raku 1, and maybe try to understand how it works. So let's keep the code. Right. No, I didn't copy this. Copying is right. Okay. So let's look. So let's try to understand how it works. What I suggest is we just print. Right. We don't need this S, for example. No, substr. No. Yes. Yeah. So, for example, first it was an empty string. Let's make it clear. Then we did it like this. Then we say result, right, or even like this. Like then we can. Oh my God! So this is Perl 5. This is what you have to do in Perl 6 or in Raku. We do it like this. Okay, this is, what is it? This is S, right? So we never modify it, even with this with. We set the topic and we do not, or do we? No, we do not modify this, right? Because we keep we're collecting result in the dollar result, right? So we can use original string here. So I believe semicolon is required, right? So step number 2. Okay, step number 3, like this. Step number 4, and finally the result. Actually, this is already the result, right? So it's step 3, step 4, step 5, and what I need this. Right. Okay, so I hope to see every step how it works, what actually changes. So the defaults are those from the input, from the definition, from the task. Raku, right? So it's there, clean Raku 1. Hey, right. Okay, so this is the output, this is the input. So you see, so the first character is always there. Then ndr. What is ndr? It's this one. So if the count is 3, so we replace 3 characters, basically ndr. Per. So let's maybe first. So right. So if so we have the count 3 offset 4. Right. So at this offset, so this is offset. What we have to do? So we have to like the first character is replaced with character C plus 1 plus offset, right? Second character repeated with second plus offset plus 4, and finally this third character is replaced with this 3 plus 4. This is 7, this is 6, this is 5, right? So E is replaced 0, 9, 2, 3, 4, 5, 6, 7, 8, 9, 10. So character number 1 is replaced. So E is replaced with N, right? Then R is replaced with D, R, and L is replaced with 7th again with R, right? So this is the output. Raku, right? Okay, so what we see here, first there's this first character just copied to the output, then so we immediately, right, so this is what I told you, so we immediately append the whole substring with length 3 to the second position. So we made this swap not by swapping characters, right, because basically, right, so this NDR, these are the characters going one after another, starting the position 4. Actually not 4, just 1 plus 4, which is 5, right? We just put it there. Then after that we so we need to append this A, which was not modified actually in this now I understand what that K can do. So basically in our case we see that A is there, so that so the right side of those the right side of the swapping sequences is appended here. Here we append this letter A, which is in the middle. Then we append we append this ERL, which are the 3 characters on the left side, right? And finally we append the rest Raku, right? So nice, really nice. So the idea here is that we know that we do not rotate, we do not change the like relative position of those 3 characters. They were there as a solid substring, and it was the same solid substring in the output, but just in different position. Right, really interesting solution. Right, okay, so yeah, I think this is it. We looked at all these solutions in the Raku programming language for task number 1 from Perl Weekly Challenge 70. Great. So I hope you enjoyed Raku, and see you next week. Bye.